right, last time we talked about the law of sines. Today we're talking about another law, this time called the law of cosines. There is no law of tangents, just in case you're wondering. It's just the law of sines and law of cosines. So here is the law of cosines. If triangle ABC has sides of length A, B, and C as shown where we're using triangle conventions, we have side B across from angle B and so forth. If that's true, then it will always be true that a squared is equal to b squared plus c squared minus 2bc cosine A. And then there's the two other versions of the formula. You might notice some patterns here. The side that is here is always the angle that we use, and the other two are in the other two positions. This formula, in some ways, it's easier to use than the law of sines, and in some ways, it's trickier. Definitely, it's just something that you need to practice working with because obviously, you know, it's a pretty long and fairly complicated formula. But I think as long as you practice with it, you're not going to have problems with it. So here, we're going to start by finding a missing side in a triangle. So in this triangle, we know that side A is 12 and we know that side C is 16. We know that angle B is 38. We're wanting to find the length of side B on that triangle. Well, if you look at your list of the law of cosines, one of the things that I usually just use to sort of choose which of the versions you're using is the angle. Only one of those versions uses angle B. So we're going to use the formula b squared is equal to a squared plus c squared minus 2ac cosine b. So we're going to use this version of the formula. If we put in the information that we know, a is 12, so this is going to be 12 squared plus 16 squared is c squared minus 2 times 12 times 16 is c, and we want to also times that by the cosine of 38 degrees. As I wrote that, I left off my power there. Be careful of that. Okay, so we've got this formula for b squared. We've filled in the information we know, and you might notice that at this point, everything on the right side of that equation is just a number. That's literally just a number that we want to calculate, and you could calculate different parts of it separately if you want, but I find it easier to just go ahead and type this into my calculator as is. 12 squared plus 16 squared minus 2 times 12 times 16 cosine 38 degrees. Make sure you're in degree mode, and as we do that, we find that b squared is equal to 97.4. And hopefully you notice here that it does not make sense that this side is 97.4. That's way too long. That's not b, and it's sometimes common for people to think they're done at this point. B is not 97.4. That is b squared. So to finally get our answer for side B, we have to take the root of both sides. So we find that B is equal to 9.9. If I round to one decimal, I'm not really picky about how you round. I probably should be, but I'm not. So B is equal to 9.9, which sort of makes sense in the context of this triangle. You shouldn't really judge your triangle by the diagram. It could always be not drawn to scale, but 97 was obviously not going to be it. Okay, we are done with this problem. We have found the side of the triangle that is labeled B. It is a little trickier when you're using the law of cosines to find an angle. In this example, we are going to find angle A. So the version of the law of cosines we're going to use is the one that features angle A. It's going to be a squared equals b squared plus c squared minus 2bc times the cosine of angle A. So in this case, this is the thing we're trying to find, and we're going to fill in all of the other information. A is 8, and B is 18. C is 13, so 13 squared minus 2 times B times 13, and we're literally just filling in everything that we know. Now, this is a common place to make a mistake. Sometimes people like to lump these numbers together, but you cannot do that. Uh, some of these numbers here are part of a coefficient. You need to keep this together. That is one thing. 2 times 18 times 13 times the cosine of A. Do not break that apart. You could even, maybe we'd probably even want to include that negative as part of that group. Don't try to do some weird combining here with this. This portion of it is the coefficient. Leave it with the cosine. What I typically like to do as I'm solving is subtract the 18 squared, subtract the 13 squared, and when I do that, I can calculate this number over here just by typing that into my calculator. 8 squared minus 18 squared minus 13 squared is negative 429. And I will go ahead and figure out what the coefficient here is. Obviously, it's going to be negative because of that minus sign there. 2 times 18 times 13. It's negative 468 times the cosine of A. And again, we're trying to find angle A. So what I would do now, as we're trying to work towards getting this A by itself, is divide. And we have, let me just calculate that, divided by negative 468 is 0.91, maybe 7. And that is the cosine of A. If you're trying to find an angle and you know the cosine or the tangent or the sine, you got to do the inverse. So let's see. If we take the inverse cosine, let me write this down. A is equal to the inverse cosine of 0.917. That means that we can find angle A. And it is 23.6 degrees. So we have found our angle A. Again, be careful in this area with not combining too many things at once. And I think we'll practice that again. All right, use the law of cosines to solve the triangle. So in this case, we have angle A is 38 degrees. We have side. Let's see if we think about the conventions. Here's angle C, so this must be side C. Here's angle B, so this must be side B. And this side over here that we don't know yet is side A across from angle A. Okay, so it looks like we know angle A, side B, and side C. Now, we could, last time we talked about the law of sines, we can use the law of sines if we have a pair of things, either the A's or the C's or the B's, but in this case, we don't have one of those pairs of things. So we can't use the law of sines here, and that's when the law of cosines comes in handy. So we have angle A, so if we're going to try the law of cosines, I think we would like to use the version of the law of cosines that includes that angle A. So we're going to use the version that says A squared equals B squared plus C squared minus 2BC times the cosine of A. Again, you can look on your formulas to get that. All right, so we're trying to solve the thing we're going to find first. So it looks to me like I know B, I know C, I know angle A. We're going to be finding side A first. So if we put in the information we know, B is 12, C is 16, again 12 and 16. And the cosine of angle A is 38 degrees. Finding a side is when the law of cosines is fairly easy. Put in the information that you know and calculate it, and then you'll have to, of course, do that square root in a second. Minus 2 times 12 times 16 cosine 38. Just putting it in my calculator, and I find that a squared is 97.4. And if we take the square root, it's 9.9. I feel like that's the one we already did, silly. Okay, I'm going to label that on the triangle, 9.9. Okay, at this point, if I want to continue solving, I now have this pair I could use. I could use the law of, you could continue using the law of cosines if you want, but most of the time, as people are doing these sorts of calculations, they'll switch to the law of sines at this point because they have that pair. So if I use the law of sines, let's see, let's find angle C. I could have just as easily chosen angle B. I chose angle C. If I switch to the law of sines, put a box here, I would do the sine of angle C over side C equals, and the one I know is A, sine A over A. So putting in what I know, side C is 16, angle A is 38, side A we calculated as 9.9. To solve that, we'll multiply both sides of our equation by 16. And now we have that the sine of angle C is equal to, and as I calculate that, I find that it is, whoops, 0.995. Again, that's the sine of angle C. So if I want to know what side C is, I have to do the inverse sine. So angle C is 84.3 degrees. Now we're actually almost finished here. So we have angle C, I'm going to add that to my diagram, 84.3 degrees. The only thing left to find is this angle B over here. Angle B, we can find very, very easily. We have two angles in the triangle. The angles have to add up to 180. So angle B must be, if we subtract the 38 degrees and the 84.3 degrees, we come up with that angle B is 57.7 degrees. And try to remember to put your degree symbols with your angles. 57.7 degrees. And we've finished. We have solved the triangle. Okay, we're going to do another example of solving the triangle. This time we have triangle ABC, which has side lengths of 10, 16, and 8. If it helps you draw a picture, you don't necessarily need to though. Let's see, 8, 10, and 16. So if this is C, so this would be angle C. 10 is A, so this is angle A. 16 is B, so this is angle B. When you're using the law of cosines, usually you'll find that the largest angle first, that's going to be across from the longest side. So I'm going to start by finding, in this case, angle B. And again, the reason I'm going to find angle B first is just because side B is the biggest, the longest side. So the version of the law of cosines I'm going to use is that B squared is equal to A squared plus C squared minus 2 AC cosine B. So if I put in the information that I know that side B is 16. I know that side A is 10. I know that side C is 8. Side A is 10. Side C is 8. And angle B, that's the thing we're trying to find right there. Now this is again the tricky case where you have to be a little bit careful just to not combine things you shouldn't combine. This is an entire entity. You cannot somehow combine these numbers with these numbers. This is a coefficient of cosine. So just be a little bit careful as you're doing that. So what I would do is subtract the 10 squared, subtract the 8 squared, and you could calculate those values separately and then subtract those numbers, but I just usually subtract it with that squared symbol because it's faster usually. So 16 squared minus 10 squared minus 8 squared is equal to 92. And now I can figure out this coefficient here for my cosine. Negative 2 times 10 times 8 is negative 160, and that's the coefficient of that cosine B. Now that I have it sort of simplified, I can divide by the negative 160. To find that we have negative 5.75 is the cosine of B. And again, when we need to find an angle, we'll do that by taking the inverse cosine. So I find that angle B is 125.1 degrees. I think it's worth mentioning here that law of cosines does not have an ambiguous case. So that's probably good news for some of you. Okay, I wrote gigantic. Luckily, I'm using a smart board, so I can shrink it, maybe. Maybe not. Here we go. Shrink, shrink, shrink. Okay, so we found angle B, and I'm going to label this in here, 125.1 degrees. Well, now that we have this pair of B's, both angle B and side B, now we can switch to the law of sines if we would like. Now, if you love the law of cosines, you could continue using the law of cosines as well. Typically, I switch to the law of sines. So let's see, I'm going to find, and it doesn't really matter, you could find either angle A or angle C. I'm just going to choose to find angle A. So to find angle A, if I set up a law of sines, I will put sine A over A is equal to, and the ones I know that can help me are the B's, sine B over B. So if I fill in the values I know, side A is 10. Angle B we just calculated as 125.1, and side B is length 16. Solving for A means I'm going to multiply both sides of my equation by 10. And I get that the sine of A is equal to, I can calculate this number in my calculator real quick. 10 times the sine of 125.1, all divided by 16, gives me 0.5113. So to find angle A, I would do the inverse sine of that number. To find that angle A is equal to I'm around 30.8 degrees. So now I can add that to my diagram. I now have angle B and angle A. Angle C is going to be easy peasy because we know that the angles in a triangle add up to 180 degrees. So if we subtract the 30.8 and the 125.1 from 180, we find that angle C is 24.1 degrees. Usually the first thing you find takes the most work, and it slowly becomes less work as you go along. And that last one was really easy. Okay, so we have solved this triangle. We're going to do an application, and I believe that's it. Let me just check. Yep. Okay. So example 5, we've got this little application. A boat is they leave the dock and they are going on a little cruise. So they cruise over to the Garden Island and then they go on to Hidden Island. And we want to know how long is it going to take them to get back to the dock if they go to the dock on a straight course and if their speed is 12 miles per hour. Well, first of all, if we want to know how long it's going to take them and if we know their speed, we've got to know how far they're traveling, how many miles. So we can set up a little law of cosines equation here to help us. We have side B across from angle B, and we have side C across from angle C. The angle that we have is angle A, so we're going to use this version. If you accidentally pick the wrong version, when you try to put your numbers in, you're going to find that you have too many variables, and that's going to be a clue. Oh, I almost said sine. It's always cosine. Oh, sorry. Okay, always cosine for law of cosines. That's why it's called law of cosines. All right, if we put in the stuff we know, we have a squared is equal to 18 is b, 31.5 is c, that's going to be squared, and we have to use the b and the c again. And that's multiplied by the cosine of angle A is 100 degrees. Now this is our really straightforward case. It's pretty easy to use the law of sines to find a missing side. So if we crunch those numbers in our calculator, we come up with that a squared, and don't forget that's not a, that is a squared, 1513.17. That's probably good enough. And now if we want to know a, we have to do the square root. And we find that a is about 38.9 miles. I'm going to add that to my diagram. Okay, so my question though didn't say how many miles do they have to travel. It's saying how long is it going to take them to get back to the dock if they're traveling at 12 miles per hour. Well, they're going 38.9 miles, and for each group of 12 miles it's going to take them an hour. We just have to divide. 38.9 miles divided by 12 miles per hour would give us that it's, whoops, I didn't I didn't type it right. 38.9 divided by 12, I missed the one. About 3.24 hours. So pretty close to 3 hours and 15 minutes as they're traveling on the boat. Okay, the only last thing I wanted to talk about is sometimes it can be difficult to tell whether to use law of sines and law of cosines. And there's a bunch of letters here that tell you what to, which ones work with which law. I think what it really just boils down to, though, is you have to look at your triangle and decide if the information that you are given includes a pair. If you have both of the B's, or if you have both of the A's, or if you have both of the C's, then you can use the law of sines. The law of cosines is what you would use when you don't have a pair that can be helpful to you. The only tricky thing to be careful of is sometimes in the law of sines, if you know this angle and this angle, and you know this side over here, sometimes you don't realize that you do know this angle as well. In this case, it would be a 30-degree angle. So that's the only thing to be careful of. This case, you can use the law of sines. The reason law of sines works, though, is because you know this angle, even though at first it might not seem like you do. But anyway, look for pairs. If you have a pair, you can use the law of sines. If you don't have a pair, you have to use the law of cosines. So here you have all the laws on the back of your paper. I will give you a formula sheet that you can use on your test. That's it for today's lesson.